and I really don't even know how to use that now. So
Oh, really? Were you not using it on something else?
I was using it on something else, but I don't know the difference. Like when we tried to get in, like I can't figure out how to get into it from the, that Crossroads purchase.
Yeah.
I can't figure out how to get to that because usually I've gone through the BYU website.
Yeah.
And then you just double click on where it says like wrong site or whatever. Yeah. But
yeah, that's all I do.
Yeah, well, this nothing comes up. It just comes up some IBM thing. And so I don't know. I don't know.
I think when my SPS loads, it says IBM something while it loads. But then,
does it?
Yeah, then it flips over and I mean, I guess I can't remember, but yeah, it says like IBM statistics or something, and then it opens up. But yours doesn't open; it just is stuck on that screen.
Yeah, it's stuck on that screen, and so I don't know what. Yeah, it's kind of stressing me out.
Yeah, you're going to need that for this test.
I know.
So. Can you access it the way you were before?
Yeah, I can go. Yeah, that was my husband's laptop. So hopefully, I think he leaves tonight to go to Phoenix, which is 3 hours away from my house.
Yeah, that's not conducive to it.
So I'll have to figure it out tonight. So.
Well, I figured I have to take my test as soon as we're done with our review, because then I have to go to work tonight, and if it closes at 2 o'clock tomorrow afternoon, I won't be able to take it any other time.
Is that what time it said it closes? Is it 2?
I think so.
Oh, well, that's crazy.
I could be wrong.
Well, I read somewhere that, I read your post because you were worried if you needed 4 hours. I read somewhere that she said it doesn't really take that long. It's just you can't leave and come back. You have to, be done within 4 hours when you start. Yeah. So.
Well, I wonder if she just posted that, because when I looked at my stuff I don't know when, probably about 3:30 this morning when I was at work, she hadn't answered, and I thought that's very helpful to post a question and not get answers.
I know. No, she does that a lot because she left out of town. And so she's going to be out of town, but she said she would check. But I read it somewhere. I think I read it in the very introductory to this week's.
Oh.
Yes. I think I read somewhere that she says most people don't take that long.
Well, hallelujah, because I'd like to go back to bed and take a nap before I have to go back to work again tonight.
Yeah. I hope Ryan comes, because I'm not I don't know if I'm going to be that much help on this quiz today.
Well, so did you go through them?
Yeah, well, I tried, but my kids were out of school yesterday because we had a snow day. And that just makes when my kids are home, it just makes everything.
Wait, you live in Arizona. You had a snow day?
Oh, yeah. No, I live at 7,000 feet. I'm in the mountains. Yeah. So,
okay.
Yeah, no, we had a bad storm come through. And then we had a 2-hour delay this morning. So I've just been a little crazy.
Yeah.
Yeah. Oh, good. There's Ryan.
Hi, Ryan.
Hey there.
All right. Well, I say we start because it's a long review.
Yeah.
Yeah, sorry. I've been here for like 6 minutes. I could see you. I just couldn't figure out how to join.
Oh. I guess there's advantages to being the host.
Yeah. No, I've been there, done that. I could hear you guys and see you guys, but you couldn't see me or hear me.
All right.
All right, so this is a long one. If it's the exact same review that we did in the book.
Yes.
Which I just wrote my answers down.
Are they in the same order?
Yeah, they look like there's a couple.
No, because my answer to number 1 is central limit theorem, and that's not the first question.
Oh, you're right.
Yeah, but number 3 is the same. So 1 and 2 is different, but all the rest of them are the same.
Right. Okay.
Let's see.
So should we get started?
Yep.
Yeah.
Let's do.
I can
Okay.
start with 3.
Yeah, you go.
Which of the following variables is categorical? The number of animals, randomly selected brand of toothpaste. That's the one. Is that what you guys got?
Yeah.
Well, I was confused on this one, which I will be on almost all of them. But that's how I missed a question like this on the quiz.
So this one's easy, Becky. If it's something that you can quantify in a number, then it's numerical. If you can't put it in a number format, then it's categorical.
Okay.
So, like the number of animals in the zoo, you could answer with a number. That one's numerical. Age in years, you can answer in number. So that's numerical. But randomly selected brand of toothpaste, there's no way to say that with a number, so it's categorical.
Categorical. Okay, cool.
All right, so the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is or are true? Let's see. On my notes, if it's the same question, I have parameter is 100 and the stat is 112.
That's what I put too. So parameter is the true value, what it actually is, and and the statistic is whatever you got from taking a sample.
Right.
So the answer is going to be 112, isn't that? They want
and
a
one.
statistic. Oh, and 100?
It lets you choose multiple. Yeah.
Oh, okay. Okay. All right. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they are very considerably from neighborhood. Oh, vary. Sorry. From neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property value. What type of sample would we collect to gauge the residents' response to a proposed increase in property taxes? Oh, I don't know.
I wasn't sure if there was a clue that told you one better than another, but I went back in my notes, it always said just a simple random sample was the best sample, so that's what I put.
Sorry, we're on number 5, right?
Yeah.
Yeah, I think it's stratified because we've got 4 different groups and we're taking a random sample of each one.
Okay.
Yeah.
I totally missed that.
Yeah, that the groups each. Okay.
Oh, because of the 4 distinct neighborhoods.
Yeah.
Okay, that would make sense. And so, stratify. Yeah, okay.
So number 6, when designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sample scheme is implemented? And I put that this was cluster sampling.
That's what I said too.
Yeah.
School fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? And that one's just a simple random sample.
Yeah.
Okay. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? Is it the simple random sample?
No,
I think it's stratified.
I put stratified too because they took 2 groups and then took a simple random sample of each group.
Of the group. Okay. That makes sense. Okay.
For 9 and 10, I just got a new computer and I haven't set up the new software on it yet. So I didn't get to those ones.
Okay. Well, I'm having
Well,
a
I
problem
did make a
getting-
histogram though. I did 11.
Yeah.
All right, so let's see. So for 9, that survey was taken. Can use this data, calculate the mean. All right, well, so
Does it-
had a
Does it
mean.
give you the mean? Does it just give you the mean from the histogram?
Of 4.77.
Not the one I made. I made a bar chart.
Okay.
And then the standard deviation was 1.912. I created a histogram. Yes, I did.
So what'd you get for your standard deviation?
So I had 1.912.
And then what did you get for the mean?
For the mean, I had 4.77.
And there's no third decimal on that?
There must not have been. I just had, that's what I had written.
Okay.
Okay, I'm going to have to do that because I have a new software too and I can't figure it out. Okay.
Okay, for the next one, we get to do the seals. So basically, they take a temperature rating of a bunch of seals, and we get this data here.
Okay.
Then it asks, what is the value of the number that goes in the position marked with an A in the table above? And for that one, let me make sure these are matching up still.
I know, I was going to say, I have numbers that don't seem to match. Because I had it was number 11, and it was a negative 0.165.
That's what I got, and I think that still matches.
So what do we...
Oh no, you're right. We're on question 12 now, so they don't match up anymore.
So we are taking 37.91 and we are subtracting it from what number? How many seals are there?
So we have to calculate the mean.
Oh,
So it doesn't give it to you, but mean is just the average, right? So
Right.
you just
The average.
add up all the numbers
and
that
then
it gives
divide
you,
them.
and then divide by 4.
And then for number 13, it wants us to calculate B, and I get a 0.681.
That's what I got too. Just a minute, I'm trying to still type in my...
Okay.
We're doing negative on my computer.
So what did you guys get for your mean? 38.07? Or did I add those wrong?
38.075 is what I have.
38.075. Subtract it from 30. So you got for A 0.165?
Yeah,
And
negative
then
0.165.
Negative 0.165. Okay, and then for 13, you got 0.681.
Yeah.
Okay, is it me to read? Are we on 14 yet?
Yeah.
Okay. What quantity is equal to the sum of the numbers in the squared deviation column? What? Oh, that number. That's the standard point.
It's the variance is what I got.
I actually put none because the variance is the sum. I had written down that the variance is the sum divided by n minus 1.
The variance is, but that's at the very end after we've added everything up. Isn't the variance where you take the number n, which is of all the samples, minus 1.
Yeah, so you add them all up. I just, in my notes from my little chart that we had, there were the 5 columns. So we're in the 3rd column over where you square everything and add it all up. But then I have sum divided by your sample size minus 1 equals the sample variance. And see, the question just asks what the sum of all the numbers is.
Because it's the squared. Remember at the very end where you square the
so then
deviation?
you square that and it gets your standard, you square root it and it gets your standard deviation.
So that doesn't give you your variance, the square.
Oh, let's see, what?
The variance is the step before
Square.
standard.
Well, I'm going to put none. If you guys disagree, put the one you think and we'll see who gets it right.
Okay.
No, none is correct.
None is correct. Oh, hi, Josephine.
Hi.
Cool. Josephine, did you already submit yours?
No, but I did mine before the group meeting.
Okay.
But I haven't submitted it.
Okay, and that's what you believe it is none of these is correct?
Yes.
Okay. Okay, Josephine, why don't you read 15?
Okay. What is the standard deviation of these temperatures? When I solved mine, I got 0.715.
Yeah,
That's what I get.
30, oh, I just did it, 37. Oh, wait, was it 38.075? Is that what you guys said?
Yes, that's the mean.
Is it, okay, 38. Okay. I don't know whose turn it is now.
I don't know. Under certain conditions, the standard deviation can be negative, and that's false. It's always true. Or, I mean, it's always a positive number.
Right.
Yes.
Question number 17, we take more samples of more seals at different locations, and it asks which location resulted in the most consistent temperature measurement from one seal to another. And I would say it's the one with the smallest standard deviation, being the extradural.
That's what I chose to.
Write that down.
Now, would this change with the sample size? Do we need to take that into account? Or can we really just look at the standard deviation?
Well, I don't know. That's a good question. I just simply looked at the standard deviation.
Yeah, I did too.
But
What did you get, Josephine?
does it change if we do it by the sample size?
I don't even know how to use sample size to change it.
Maybe
I
we're
just
making it
realized they're
harder.
different.
Maybe we'll make it harder. If you guys both thought it was the standard deviation.
Yeah, I think it's just extradural because it's small standard deviation.
Okay. Okay. I can define standard deviation in my own words.
Yes.
I can maybe type it in my own words, not explain it. Okay.
All right. So then, oh my numbers are off. So what's the 3rd quartile on this one?
Is that going to be 8?
I had 8.
That's what I put.
But now I have a question.
Uh-huh.
When you do your 5-number summary and you have your minimum and your maximum, do your outliers count as a maximum, or is the maximum 12?
I think it's 12. I wouldn't include the outliers. I think that's why they're
outliers
called
don't count.
outliers. Like, I think the definition of that right-hand whisker is the maximum. Like, that's what it's defined as.
All right, because I couldn't remember. All right, that's good to know. So 12 would be the max on that.
Let's see here.
Is Josephine still here?
It's on here.
Okay. I think it's your turn to read, isn't it? On 20.
Okay, what percentage of the data lies between 4 hours and 8 hours? I chose 50%.
That's what I chose, was 50%.
Yeah, 50.
Okay.
Okay, number 21. So we measure the nitrate levels in Rexburg's water, and we get we get a range here. And the question is, estimate the mean of the measured nitrate concentrations in Rexburg's drinking water. So for this, do we just add the bottom of that range to the top of that range and then divide by 2?
That's what I did, because that was the only information we were given.
Yeah,
So I got 2.055. Is
that's what I got.
that what you guys assumed or did?
Yeah.
Oh my god.
Okay, so then using that same information, estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. So then I used that 2.055 as my mean and plugged it into the formula and got 0.657.
Ooh. I got 0.2325.
Oh, that's way off.
So the way I did it was each of those ranges was 2 standard deviations away from the mean.
Yeah.
So I take the mean minus that end of the range, and then divide that by 2, and that would give me 1 standard deviation.
I just plugged it through that whole big long
the
formula
applet?
where you take each one, subtract the number from the mean, then I squared them, then I divided it all by the n minus 1, and then square rooted it.
Hmm.
What did Josephine get?
I didn't solve that one.
I didn't solve it either. So this isn't one that we would put into the applet. Is that what you're saying?
I don't think it is.
No,
Okay.
so it doesn't go in the applet, but you should be able to put it in a graph or a table, just like the one kind of up above, right? That has the mean and the standard deviation, just the longhand formula for figuring out a standard deviation, don't you think?
Mm-hmm.
I don't know. Cause that was one I never really understood the whole variance and figuring out the standard deviation thing that well.
Okay, so if you want to figure out a standard deviation by hand, long way, instead of them giving it to you, if you have your 5 columns, so they all go vertical, right? So then you start each one just like you start all the rest of them. So you take the number that it gives you, so the first one would have been the 1.59,
5.9.
and subtract it from your mean, which we decided was 2.055. And you get that number. Let's see, I gotta write my other one down. So 1.59 minus 2.055. So that number is a negative 0.465. And then you square that number.
Square.
And I come up with a squared number of 2.16. Are you with me so far?
Yeah, I'm following you.
Okay, so then when you get to that point, you have to do the same thing for the other number.
The
So that's 2.52.
2.52.
Subtract your your mean, so subtract 2.055. And you get, and because they're the same deviation or the same deviation away, just a positive, negative, my answer was the same. It's just negative versus positive. So I got a 0.465. So then when I square that, I have 2.16 in my squared column. Yes?
0.216.
No, 2.16. So from my first one, I end up with 2.16, and from my second one, I end up with 2.16.
See, and I end up with 0.216 because you.
Yeah, I ended up with 0.216. Because when we subtracted it, we got 0.465, and then we square rooted 0.465, which is 0.216.
No, don't square root. Times it. You're squaring it. So when you get 0.465,
Yeah.
then you times it by 0.465.
And what do you get when you do that?
I got
Oh,
0.216.
Yes,
Yes.
you did. But wait, what did you get on the so did I do the first one wrong? Is that what you guys got on the first one? 0.216? Have I got my decimal place in the wrong thing the whole time?
Yeah, because both of them were the exact
It's the
same.
same.
Just one was a
Okay.
negative and one was a positive.
Perfect. Okay, so I got my decimal point in the wrong place.
Okay.
Good. I'm just checking to make sure you guys are really working along.
So
All
on
right.
number 22, that's what you got, 0.216.
No, that's not the end of your question.
Oh,
You're
crap.
only halfway through this problem.
Okay.
So that's your squared column. Now you
Okay.
have to add your squared column. So you put your 0.216 plus 0.216, and you end up with 0.432. And then this is where you have to divide by your sample size minus 1, which is actually still 1. So it doesn't change your thing, right? So 0.432. And then you have to, right, no, that's your sample variance. That's your sample variance.
Okay.
Then you square root that to get your standard deviation, which is 0.657.
657. And that's your.
That should be your standard deviation.
So look at this then. If you take 0.657, that's one standard deviation, right?
Yeah.
Mhm.
And you add that to our mean of 2.055, that gives you a 2.6, that gives you like a 2.7,
Yeah,
which is
2.712.
higher than the range
Not
we
what
were
it
given.
says.
Oh, because the range is from 1.59 to 2.52.
Yeah,
Right.
because
And
you're right.
2.57 is supposed to be two standard deviations.
Yeah, so that doesn't work. Why doesn't that work though?
Hmm.
Okay.
So that's why I think the distance between our mean and either of those numbers, you cut that in half, and that's one standard deviation.
So 0.657 divided by 2?
No, so I took our mean of 2.055 and I subtracted 1.59, and that gave me a number, and I divided that number by 2, and that's what I used for the standard deviation.
2.155 minus 1.59.
Well, that makes sense. Why do they teach us a big longhand way to do that?
I don't know.
So you got 0.233.
All right, I agree.
Yeah.
with that one.
Okay, that makes sense. All right. We ready to go on? Is it my turn?
So,
Okay. Between what two measured nitrate concentrations do approximately 68% of the data values lie?
So this one, we decided one standard deviation is 0.233, right?
Right.
So we just add that and subtract that. So
I got 1.82 to 2.28.
Yeah, 'cause I had the deviation wrong, so my answer won't be right.
So how did you do that again?
I took our mean and I added 0.23 and then I subtracted 0.23. Because 68% is one standard deviation.
Okay. Okay. That makes sense.
Okay, so then what's the value of the mean of the standard normal distribution? That's the same. The mean's the same. So
I think it's 0.
why is it 0?
Because now we're not talking about the drinking water anymore. We're talking about just in general, when you look at a standard normal distribution, what value do we give the very center? And this is like in the applet, when we use the z-score, if you look at it, the very center of that is 0. And that's what it's talking about.
Oh, I totally didn't get that.
And if you look up at the top of the review page where it says show lesson summaries, you can click on that, and one of the summaries tells you that. It says, oh, I read it word for word from there.
Okay.
Okay. So, but then how did you do number 25? Because I was
Yeah.
applying 24 and 25 is still our
Is it 1?
water problem.
Yeah, so the lesson 5 recap says a standard normal distribution has a mean of 0 and a standard deviation of 1.
Oh. All right, I totally missed it out.
So 25 is 1.
Correct.
Yes.
Okay. All right. Wait,
So
this
now
is,
we get to talk about the GMAT exam, and let's see here. It's been shown that the scores of the GMAT are normally distributed with a mean of 542 and a standard deviation of 120. The minimum GMAT score required for admission into this program is 500, but is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student will score above 542.3 on the GMAT? So this should just be 0.5, right? Because
That's what I said, because it's
yeah.
just 50%.
Yeah. And then after that, the next ones we have to actually calculate stuff.
so on 26, you guys got 0.5.
Right. Because it's the mean, so it's right there in the middle.
Oh, that's easy. That's nice.
So what is the probability that a randomly selected student will score below 600?
Okay.
So I got a z-score of 0.479. And then it gave me a probability of 0.684.
That's what I got.
Okay. So
So
the next
then,
one is the score above 600.
right. So I just took 1 minus our answer from the previous one and got 0.316.
And that's what I got as well. And on number 29, I went to the applet and I selected the left-hand side and I put in an area of 0.1 and that gave me a z-score of negative 1.282. And then I plugged it into the formula and calculated a 387.768.
That's what I got too.
So the 29 is 387.768.
Yeah.
Yes.
It's the nearest whole number.
The
Oh,
nearest
There's a
whole,
number.
good catch, Josephine.
388.
388.
That's just silly if we got it wrong for that reason. Man.
Okay, find the GMAT score that corresponds to the 90th percentile.
I got 697.
Me too.
Okay, find the first quartile of the distribution of GMAT scores.
So
Round to the
basically,
nearest whole.
it's asking the same question, only it wants 25%, right?
Right?
Mhm.
So I got 461.
That's what I got. And then on 32, it's the same thing, but it's asking for 75%, and I got 624.
Yes, me too.
Okay. Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean score for all such samples?
Wouldn't it just be the same as the normal thing? So it's like 542.3.
Yes.
Yeah. Mean.
So the standard deviation is different.
Right. Now we have to do the standard deviation before and divide it by the square root of 15. Is that right?
And that one I got 31.123.
That's what I got.
So what was the standard deviation that we take on that one?
You take the standard deviation of the sample, and then you divide it by the number of people in this sample.
Divided by the number.
Or rooting.
Yeah, the square root of the number of
Okay.
people.
Of the number of people.
So the square root of 15.
Okay. All right.
So the probability that the sample mean for the score of 15 students will be greater than 600. So I had a z-score of 1.854. And when I put that in my probability applet, I got 0.032.
That's what I got. Shall I submit
All on
it?
the same page?
Yeah.
I'll submit. I'm not scared.
Okay.
We got 100%.
Oh, sweet.
Go team.
Wow,
Okay.
you guys are awesome.
Yep.
I hope I don't get an F on this test.
You'll do fine.
Just
I
go
don't
back.
know about that.
If the test is just those, that won't be too hard. Plus, we can use 1 page of notes, right?
Yeah,
Yeah.
yeah.
Okay.
All right.
I missed one.
Oh, really?
I must have wrote 15 down wrong. What did
Which
you guys
one?
get for 15?
0.715.
I did 38.075.
Oh, darn.
I know. I remember thinking 38 seems like really high.
Oh, that was our mean for that problem.
Yeah, I messed up. So,
All right.
hey,
Okay, very good. I'll post it.
All right.
Good luck, everyone.
Thanks,
Good luck.
guys. See you Thursday.
see
Okay,
ya.
bye.